To start, problem 1, how many dots, how many valence electrons are each of these compounds going to need? That is all we're trying to do with part 1. So there's my pattern. 1, 2, skip, 3, 4, 5, 6, 7, 8. What do you think? H2, how many dots? 2. Each hydrogen has 1. H2 means 2 hydrogens, so we have 2 dots. All right, N2. What do you think? How many dots? You're like, I don't know. Well, go find nitrogen. Nitrogen, hey, that's in the column that has 5 valence electrons. So 5 dots. I have N2. 5 and 5 means 10. All right, we did C2H6 just a minute ago. How many dots for C2H6? 14. And if it helps, you can do it this, by the way. You could go, all right, I got 2 carbons. That's 8. 6 hydrogens. That's another 6. Hey, 8 and 6, that gives me my 14. All right, now a little bit trickier. Cl3, C2F3. How many dots? Note, 3 chlorines. This is in the column where each one has 7. 3 of them, that would mean 21. 2 carbons. Carbon is in the 4 column. 2 of them, that would mean 8. Fluorine, another halogen, another 21. 21 and 8 and 21. 50 total dots in that diagram. You'll have the 2 carbons in the middle surrounded by the 6 chlorine and fluorines instead of 6 hydrogens. All right, last one, E. How many dots in SO4 2 minus? 32. And again, sulfur. There's sulfur. It has 6. Oxygens have 6, but I got 4 of them. So that's 24. And that 2 minus means another +2. That's the ion part. So 6 and 24 is 30, and 2 is 32. So that diagram has 32 dots. Like I said, on a quiz or a test, that would be the whole question. How many dots? How many valence electrons in the diagram? All right. Now, we went through our notes just a moment ago, so what do you think? Single bond. How many valence electrons in a single bond? In a double bond? In a triple bond? Again, this is not hard, okay? Just pay attention. 2, 4, 6. All right, now, here's what I want you to do. Before we worry about what goes inside the boxes, I want you, I'm going to give you a couple of minutes to do this. I want you to go through each of the compounds and put below it how many dots it would have. Now, we already did H2, so we know that's 2. We've already got the C2H6, that's 2. We already did the SO4 2 minus, we said that's 32. So that, you already got some of them. But, you know, how many in F2? How many dots would be in F2? Again, go back to your pattern. I got 2 fluorines. So how many dots? 14. All right, so I'm going to give you a couple minutes. Go through the rest, and just underneath, put how many dots will be in our diagram. When we get to the test on this particular unit, the two trends, if you will, one for how many valence electrons and the other one for charges, those are the most important patterns, if you will, that we will use in this unit. Did I do it right? Are you getting the same numbers? All I'm doing is however many times it is. So if I got 2 carbons, each one's got 4. 3 carbons, each one's got 4. 4 carbons, each one's got 4. Don't make it hard. And then the last 2 were in our notes that we just got through looking at. So, we okay with this? That's step 1. How many dots? Any questions on this part? All right, now, we're going to start making our diagrams, and we're going to go to step 2 now, which is, hey, what's in the middle? And then arrange the other ones around it. But, hey, part A, we only got 2, H2. So that's all it's going to be. And part B, that's only got 2. So we're just going to go that far for right now. We're just going to do those 2 because they're diatomics. There's only 7 of these, by the way. And they're all gens, as I like to call them. Hydrogen, oxygen, nitrogen, and the 4 halogens, F2, Cl2, Br2, and I2. Those are the only ones that come in 2s. Everybody else has to have other things connected to it. So that's our step 2. We only have 2, so we just put them down. Now, step 3, put in the bond. Okay, there's our 2 dots. We're done. That was part A. We have our 2 dots. We put in our bond. Hydrogen can only have 2 dots. That one's done. Okay, B. There's our bond, 2 dots. Now, I got 14 dots, so I got 12 to go. There's 2, 4, 6, 8, 10, 12. I've used all 14 dots. 2, 4, 6, 8, 10, 12, 14. Does each fluorine have 8 around them? Yep. Please note, I don't need 16 dots here. I only need 14 because they're sharing the middle 2. And then I need 6 around and 6 around. So I only need 14 to take care of 2 atoms, potentially. So that one's done. Has a single bond. All of the halogens can bond like this one. F2, Cl2, Br2, I2. They would all look very similar to that one. Okay, we did C in our notes. Carbon's always the middle. Hydrogen's around the outside. Go ahead and put in your bonds. And there's my 14 dots, and C is done. Two, 4, 6, 8, 10, 12, 14. Each carbon has 8. All the hydrogens have 2. I've used up all 14 dots. Note, again, the importance of making things line up horizontally and vertically. So it's easy to tell that everything is there. Any questions so far? Seem that difficult, really? I mean, as long as it's all single bonds, this is the way it should work. All right, you go do D. Look at C, now do D. It's going to have 20 dots, but first, what goes in the middle? Look at C. D should look a lot like it. They're very similar. What's in the middle? The carbons. What's around the edges? And oh, by the way, how many places were there to put those hydrogens? 8. How many hydrogens did we have? 8. Just like here, there were 6 spots around the 2 carbons. There were 6 hydrogens. We want to fill up shells. Now we can put in our bonds. There's 8 dots. 14. 20. Any questions? All right. Look at E now. What's in the middle? The carbon. By the way, hydrogen can never be in the middle, and the halogens can never be in the middle because they can only bond once. So I got to have a carbon in the middle, and then basically the 4 spots are where the other 4 go. And it doesn't really matter if you want to put the hydrogens up and down or the hydrogens on the right side. You got 4 spots. Carbon in the middle. Put in my bonds. I've used up 8 dots. I have 20 dots. Now I go around the outside atoms, except hydrogen, to get to 8, unless I run out of dots. 8, 10, 12, 14, 16, 18, 20. And a couple of things to note here. If you're not careful, if some of the letters are bigger than other letters, you could see how it could get messy real fast. Notice how, where to put these dots kind of It wouldn't take much to get them off. You want to make sure your letters are all the same size. But there is E. F. What's in the middle? Carbon. And I got 4 of them. So yeah, I'm going to put all 4 of them in the middle. Now, note something. It says H9. That's actually kind of a clue. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many spots are left? 1. That's where the OH goes. Don't put the H there. You got to put the O there. Oxygen can bond twice. It's got 2 holes. Hydrogen's always got to be on the outside. But the molecule actually gave me a clue. 4 carbons, 9 hydrogens, and then an OH somewhere. The one spot that was left. Put in your bonds. And by the way, I have used 28 dots at this point. 30, 32. All the carbons are surrounded by 8. The oxygen is surrounded by 8. All the hydrogens got 2. That one is done. All right. G now. Remember we said that when they have the same number of dots or the same number of holes, we put the one that occurs fewer times in the middle. So we put that sulfur in the middle, surrounded by the 4 oxygens. Likewise on H, I'm going to put the nitrogen in the middle. It has 3 holes. Hydrogens never go in the middle, and I'm going to surround that one like that. See how similar these two look? And oh, by the way, we haven't done our dots yet, but these are ions. And so I always put my ions inside of brackets and then put the charge outside to say that I have added dots or taken away dots. Now let's take care of G. Put in my bonds. That takes care of 8 dots. Now I'm going to go through the oxygens until I run out. So 4, let's see, that's 10, 12, 14, 16, 18, 20. Again, notice if I get a little sloppy on it, it's harder to tell the pairs of dots. Now I'm up to 26, 28, 30, 32. In H, when I put in my bonds, I've used up my 8 dots, so that one's done. Now, I'm going to jump down to K and L because they were in the notes. We already did those. Okay? K, 2 carbons in the middle. 4 hydrogens. Put in my bonds. Note I'm already at 10. 2, 4, 6, 8, 10. I only have 12. I only have 2 dots left. But I have 2 spots that are empty, which means I'm going to be missing 2. In other words, if I really pay attention, I can catch when I'm going to have a double bond. I'm missing 2. Think about F2 for a moment. Okay, 14. Here, none there, none there. I need my double bond. I'm going to be missing 2. Likewise, on L, and again, if I put in my bonds, I've used 6 dots. I only have 10. I got 4 more to go. But if I look, I'm going to need 2 here, 2 there, 2 down here, and 2 down there. I'm going to need 8, but I only got 4. I'm going to be missing 4. Therefore, a triple bond. So those were from the notes. So I wanted to jump down there, but now let's go back up to I and J. First off, these are diatomics, so I don't have to worry about the middle. That's got 2 oxygens. That's got 2 nitrogens. Okay, they have a bond. Yeah, I know the answer, so I'm cheating a little bit, but how many dots have I used? How many have I used already? How many are already here? 10. How many dots do I have left? But how many dots am I going to need? I only have 2 dots left, but I need 4. I'm missing 2 dots. This one is going to have a double bond. Please note a little pattern there. But I only have 12. Probably going to end up with a double bond kind of situation. Likewise, how many dots have I used? 6. How many are left? 4. But how many do I need? 2, 4, 6, 8. I need 8. I don't have 8. I only have 4. I'm going to be missing 4. Triple bond. So this is a short, if you will, introduction into doing Lewis dot diagrams. This should be done now. Make sure you take a picture and submit it. Your homework will just be doing the same kind of thing on your own with other molecules. Any questions?